Hello everyone. Today we will going to see some practice questions from the chapter P block elements. This is part 4. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. This is our index slide. So today we will going to see some practice questions from question number 28 to question number 35. Let's start with the question number 28. Which of the following is the wrong statement? Options are O3 molecule is linear, ozone is violet black in solid state, ozone is diamagnetic gas, ONCl and ONO negative are not isoelectronic. You have to select the wrong statement from the options. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the answer. So it is the correct answer is option A, that is O3 molecule is linear. So basically this is the statement which is incorrect from the options, because you know that O3 molecule is sp2 hybridized, like three atoms of oxygen are bonded together, and the molecule is sp2 hybridized and it has a bent shape. Okay, 120-degree bond angle is present, so it has a bent shape, not a linear shape. That's why O3 molecule is linear is a wrong statement, and the option A is the correct answer. Okay, let's move to the next question. Question number 29. Which of the following statements regarding sulfur is incorrect? So we have to choose from the options that regarding the sulfur properties, which of the statement is incorrect? Options are sulfur molecule is paramagnetic. The vapor at 200 degrees Celsius consists mostly of S8 rings. At 600 degrees Celsius, the gas mainly consists of S2 molecules. Or the oxidation state of sulfur is never less than +4 in its compounds. So you have to select the incorrect statement. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option D, that is the oxidation state of sulfur is never less than +4 in its compounds. So as you can see that according to the option A, S2 molecule is paramagnetic due to unpaired electrons in MO, that is magnetic orbital, and is blue colored compound, thus true, right? So the statement given in the option A is the correct, and the vapor at 200 degrees Celsius consists mostly of S8 rings, thus correct. So this is the statement which is given in option B. Okay, in the first option A, about the S2 molecule is given, which is paramagnetic due to the unpaired electrons in molecular orbital, and it is blue in color, that's why it is correct. And similarly in the option B, the vapor at 200 degrees Celsius consists mostly of acid ring, which is the statement given in the B option, which is the correct statement. Okay. In the option C, at 600 degrees Celsius, the gas mainly consists of S2 molecules. This is the statement and this is the correct concept. Thus, the statement is correct. In the option D, oxidation states of sulfurs, if you see, in H2S it is -2, in S8 it is 0, in S2O3 2 negative it is +2, in SO2 it is +4, in SO3 it is +6. So oxidation state can be less than 4. You can see +2 +0 is also consisting, +2 +0 and -2 are also the oxidation states of sulfur which sulfur can have. So that's why the statement given in the D option that oxidation state of sulfur is never less than +4 is the wrong one, right? And we have to choose the wrong statement. Thus, the D option is the correct answer. Okay, let's move to the next question. Question number 30. Which among the following is most reactive? We have to choose one option which is the most reactive from the others. Options are chlorine molecule, bromine molecule, iodine molecule, or ICL compound. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option D, that is ICL molecule. So we have to choose that which among the following is most reactive. So in the chlorine, bromine, and iodine, these all three are homonuclear diatomic molecule, right? Because you can see that we have two atoms, diatomic molecule. We have two atoms like I2, Br2, and Cl2, and you can also see that homonuclear they are because both the nucleus are same, because one bromine is connected to another bromine. Both nucleus are same. So you can say that these three are homonuclear diatomic molecule in which the electronegativity of the combining atoms which are combining to each other is same. Because the atom are same, that means electronegativity of the combining atom is same. So they are more stable and less reactive, right? Because they are related. That if the molecule is stable, it will be less reactive. Because it is stable, why it will react with someone? So because of the no electronegativity difference, because same atom are interjoining or diatomic molecule, we can see that's why the molecule are more stable and hence having less reactivity. Whereas if you see iodine and chlorine, they have different electronegativities, right? Because atoms are different, so there is some electronegativity difference between them, and the bond between them are polarized, and hence their bond between the iodine and chlorine will get polarized, and hence it will get reactive. Okay, therefore the interhalogen compounds ICl are more reactive than the diatomic molecule or homonuclear diatomic molecules of halogens as given in the options, right? Thus, the D option is the correct answer, that is ICl. Okay, let's move to the next question. Question number 31. The correct order of thermal stability of hydrogen halides is, we have given the HX, some HX molecules, right? Some hydrides of halogen. We have to tell that which is the correct order from the options, which is the correct order of thermal stability of hydrogen halides. Okay, so options are the most stable is HI, then HCl, then HF, and least stable is HBr. Or the most stable is HI, then HBr, then HF, and HF is more than HCl but less than HBr. Or most stable is HF, then HCl, then HBr, and least is HI. Or most stable is HI, then HBr, then HCl, and then HF, hydrogen fluoride. So which is the correct order of thermal stability? You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C. So this is the correct order, that HF is most stable, hydrogen halide, then HCl, then HBr, then HI. You can see that as the size of halogen atom increases from fluorine to iodine, the bond length of H and X is halogens, increases. Okay, as the size increases of the halogens, the bond length between the hydrogen and halogen is increasing. This increase in bond length decrease the bond strength. Larger the bond length, smaller will be the bond strength, right? And thus the thermal stability, and hence the thermal stability will also decrease. Therefore, the correct order for the thermal stability of hydrogen halide will be, the most stable is hydrogen fluoride, then HBr, then Hi. Okay, hydrogen iodide is the least stable because iodine size as compared to the fluorine, bromine is largest. That's why the bond length between hydrogen and iodine is the largest, which decreases the bond strength of the bond between hydrogen and iodine, and thus the thermal stability decreases. And this is the correct order of the thermal stability of hydrogen halides. Thus, C option is the correct answer. Okay, let's move to the next question. Question number 32. Among the following oxoacids, the correct decreasing order of acid strength is. Again, we have to select the correct decreasing order of the acid strength of oxoacids given in the option. So, options are HOCl most stable, then HClO2, then HClO3, then HClO4. HClO4 having most acid strength, then HOCl, then HClO2, then HClO3. HClO4 having most acid strength, then HClO3, then HClO2, then HOCl. Or most acid strength is in HClO2, then HClO4, then HClO3, and then least in HOC. You have to select the correct order. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C. That is HClO4, having the most acid strength, then HClO3, then HClO2, then HOCl. Basically, decreasing order of strength of oxoacids is this, which is the reason among this is negative charge is more delocalized on ClO4 negative due to the resonance property, and hence ClO4 negative is more stable and less basic. Okay, because due to this resonance property, the ClO4 negative ion will become more stable, and thus the acid strength of that particular acid, okay, in which ClO4 negative ion is present, will be higher. So you can see this is the ClO4 negative, then this is ClO3 negative, then this is ClO2 negative, then this is ClO negative. Okay, so we can say as the number of oxygen atoms around the chlorine atom increases, as oxidation number of chlorine atom increases, and thus the ability to lose hydrogen positive increases. Okay, so all are directly related. That if the oxygen atoms number around the chlorine atom increases, the oxidation number of chlorine atom increases, and the ability to lose the hydrogen or to lose the H positive ion from the acid is increasing. That's why the HClO4 is having the highest acidic strength and the HOCl is having the least acidic strength. And thus option C is the correct answer. Let's move to the next question. Question number 33. The solubility order of alkali metal fluoride in water is. So options are the most soluble is NaF, then KF, then RBF, then LiF. Or most stable is lithium fluoride, then sodium fluoride, then potassium fluoride, then rubidium fluoride. Or most stable is lithium fluoride, then sodium fluoride, then potassium fluoride, then rubidium fluoride. Or most stable is rubidium fluoride, then potassium fluoride, then sodium fluoride, and then lithium fluoride. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option D. That is most stable. The most soluble is rubidium fluoride, then potassium fluoride, then sodium fluoride, and then lithium fluoride is the least soluble. So for a substance to dissolve, the hydration energy must be greater than the lattice energy. And due to the small size of lithium positive ion, the hydration energy of lithium fluoride is considerably high, but it has low solubility in water because of its higher lattice energy, right? Because the size of lithium is so small and they have the strong bonding, this is the stable compound, that's why it is having a higher lattice energy and low solubility in water. On moving down the group, lattice energy decreases in the alkali group, right? Results in increased solubility, and thus the order of solubility for alkali metal fluorides in water will be this increasing order down the group. Okay, so rubidium fluoride is the most soluble, then potassium fluoride, then sodium fluoride, and then lithium fluoride is the least soluble compound because it is having the highest lattice energy and low solubility in the water. Thus, our D option is the correct answer. Okay, let's move to the next question. Question number 34. Which one has highest boiling point? Options are helium, neon, krypton, xenon. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option D, that is xenon. So we have asked the highest boiling point element. As we move down the group of noble gases. Noble gases are the gases which are stable in their own and they do not react easily with any compound, right? So as we move down the group of noble gases, the molecular mass increases, by which dipole produced for a moment, and hence London force increases from helium to xenon. Therefore, more amount of energy is required to break these forces. Thus, the boiling point also increases down the group from helium to xenon. So, down the group, if you see, the London force increases from helium to xenon. That's why the bond energy will be increasing. That means we need more and more energy to break these forces, and thus the boiling point will get increasing down the group from helium to xenon. Okay, in the noble gas group. Thus, our D option, that is xenon having highest boiling point, is the correct answer. Okay, let's move to the next question. Question number 35. Argon is used in arc welding because of its which property? Options are low reactivity with metal, ability to lower the melting point of metal, flammability, or high calorific value. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option A, that is low reactivity with metal. So why we used argon in the arc welding? Argon is used in arc welding to cause the inert atmosphere around. That is without interaction with the metal. Because argon creates the inert atmosphere. Inert atmosphere means the metal or the welding will not react with anything around or in the environment or any other metal. That means without interaction with metal, and that's why argon, due to this property of argon is used in the arc welding. Okay, so argon having a low reactivity with metal, that's why it is used in arc welding. Thus, our option A is the correct answer.